Good morning, everyone. This is KP, the Math G. I was given this name by my students. I don't know why I'm called the Math G, but my last name is Kirkpatrick, so KP is that, and then the Math G. Well, let's move on. What is a derivative? And this is what I chose to teach about. I need to do a 2 to 6 minute video. I did one a while ago, 15 minutes, so I'm going to redo this again and make sure that I get it within the time frame. A derivative is a rate of change. And anytime you see in a AP question, free response question, what is the rate, okay, or the rate of change, you're going to do a derivative. If you're asked how much something is, well, that is not a derivative, but it's an antiderivative or a definite integral. And of course, you would learn that those are just opposites of each other. Okay, what can you do? You can find the slope of a tangent or a normal line, okay, with a derivative. So if the curve is like this, you have a tangent line E, something like that. A normal line would be the perpendicular to the tangent line, and of course that's the negative reciprocal. That's what the normal is. So you just have to know that as we studied, we would have to know that. But that's a lesson in and of itself. So tangent and normal lines. Okay. Here's a function increasing. Okay. Increasing. Okay. You're looking at the slope there. Really. That's the first derivative. That means you're finding the derivative for the first time. Okay. Of a given function g or f or w, whatever it may be. Then after you find that derivative for the first time, that first derivative is going to tell you whether the function is increasing or is it decreasing. Okay, it's the function decreasing. Okay, and then we get into whether a function has a max. We say relative or absolute. Max and min. I don't want to get into relative and absolute, but a max would look like this, like that. And of course, the slope is 0. We might say f prime is equal to 0. Slope has to be at the highest point. Okay, at this. All right, so this would be a max. And then, of course, a min would be just the opposite, but still the slope is 0. Okay? Alright, so f prime is equal to 0. And that's also the first derivative. Okay? That's when you take the derivative for the first time. Okay. Ooh, I'm running out of time already. Alright, and so if you're dealing with a second derivative, that's the derivative of, after you're looking for the max and min, you can determine whether this is concave up. This is concave down, concave down, concave up. If the number is negative, it's concave down. Even without looking at the graph, we know it's concave down. Even without looking at the graph, if it's positive, it's concave up. Okay. We also look for what we call points of inflection, all of those things. And then first derivative, of course, velocity, meters per second. Second derivative, the derivative of velocity is acceleration. That's the second derivative. That's going to be meters per second, which is meters per second squared. Okay. And then, of course, volume of a sphere or volume of a cone. So anyway, volume. It could be cubic centimeters per minute. And so that's what it is, a rate of change. It's always going to be in the form of a fraction like this, meters per second or meters per second squared, cubic centimeters per minute, whatever that is, okay? It's just not going to be how much water's in the tank. It's going to be how fast is the water going into the tank, or how fast is the water leaking from a tank or something like that, or from a cone, and so on and so forth. And also we get into other things such as rate of change of, well, let's see, related rates, okay, the ladder against the wall and so on, and change in y, change in x, okay, dy over dt, dx over dt, which one are you looking for, and so on. Okay, well, that's all the time that I have, and I hope I get a chance to teach a lesson on how to find certain derivatives. But this is task 1, and so this again, I'm Bobby Kirkpatrick, AP the Math G, signing off, and I always sign with a clap. So have a nice day.